In this video, we want to find the derivative of the square root of 3x squared times the square root of 10x squared plus 6. The first thing we're going to do is replace the square roots with the exponent of 1/2. There's two square roots, so we should have two exponents that are 1/2. The next thing we're going to do is make a substitution. We're going to let u equal the entire inside, which is 3x squared times the quantity 10x squared plus 6 raised to the 1/2 power. And du is the derivative of u, which we'll use the product rule. So we'll take the derivative of 3x squared, which is 6x, keep 10x squared plus 6 to the 1/2 alone. Then we're going to take the derivative of 10x squared plus 6 to the 1/2 power, which will bring down the exponent, keep the inside the same, the 10x squared plus 6, subtract 1 in the exponent, and then multiply by the derivative of the inside, which is 20x. And then we're going to multiply that by 3x squared. Simplifying this, we have 1/2 in red multiplied by 20x in red. That'll make 10x. And if we multiply 10x by 3x squared, we get 30x cubed. Okay, so after the substitution, we can replace the 3x squared, 10x squared plus 6 to the 1/2 power, and then raised again to the 1/2 power as just u to the 1/2. And we know that the derivative of u to the 1/2 is 1/2 u to the negative 1/2 times du. So here I'm using the chain rule. So this is what we let u be. We solve for du, and we said that the derivative is going to be of this form. So now it's just a matter of plugging it in. So I'm going to plug in u and du. So what I did here was I moved the 3x squared times 10x squared plus 6 to the 1/2 raised to negative 1/2 on the denominator. So the negative 1/2 would turn positive when you put in the denominator. And then this 1/2 is just 2 in the denominator. So this whole term is down in the bottom. And then for 6x times 10x squared plus 6 to the 1/2 plus etc., I saw, okay, what do they both have in common? Actually, never mind. For this one, I just kept it the same. Okay, so these are the same. So the only thing I changed was what I underlined in red. Okay, now we're going to go a step further. So I see, okay, what do they both have in common? They both have a factor of 6x, and they both have a 10x squared plus 6. But which one do I choose? Do I choose to pull out the 1/2 or the negative 1/2? Well, it's better to pull out the negative 1/2, which is smaller. So rule of thumb is always pull out the smaller exponent. Okay, so that is the negative 1/2 over here. Okay, what's left? Well, if I pull out 6x times 10x squared plus 6 at negative 1/2, the only thing that's left is really a factor of 10x squared plus 6 for the first one. And then for the second one, it's just a factor of 5x squared. So now I can just work inside. 10x squared plus 5x squared is just 15x squared. So that's what I have over here. And then everything else I kept the same, with the exception of 6x over 2, I simplified to be 3x. Now for the next step, I distributed the 1/2 power. So the 1/2 went on to the 3, the x squared, and the 1/2. So it'll be 3 to the 1/2. And then I just left the inside the same here, actually. So before, I'm going to distribute in a second, but for now I'm just going to leave it as it is. So I just distributed the 3 to the 1/2. And now I'm going to break it up. So this is where I distribute the 1/2 to all the pieces. So it's x squared to the 1/2, and then 10x squared plus 6 to the 1/4. Because whenever you have an exponent to an exponent, you end up multiplying. And the next thing I did was, okay, 3 divided by 3 to the 1/2 is 3 to 1/2. And I took this and put it in the bottom. The way I did that was I just subtracted the exponents. So I subtracted negative 1/2 with 1/4 and got negative 3/4. But that's going to be in the bottom now. So when you put it in the bottom, it's going to show up as positive 3/4. And everything else I kept the same. So for this next step, I factor out a 3 from 15 and 6. And then 3 times 3.5 is just 3 to the 3/2. And that completes the problem.